So we are come to the end of measures of deviation, which is the last topic, fourth type, standard deviation, which is also known as root mean square deviation, because it is the square root of arithmetic mean of squares of deviation from the mean. Okay. Simply, the general equation to find out standard deviation is square root of summation of x minus x bar the whole square divided by n. Actually, this is the general equation, that is square root of arithmetic mean of square of deviation from actual mean. Square root of summation x by n is average. So, square root of arithmetic mean of square of deviation, x minus x bar is the deviation. So, we are finding the squares of deviation and finding the arithmetic mean of squares of deviation, then find out the square root. That is square root of arithmetic mean of squares of deviation from its average. Average is taken arithmetic mean. Okay. So, standard deviation is the square root of mean of the squares of the deviations of all values of a series from their arithmetic mean. Standard deviation measures the extent of spread of values in a series. It is always a non-negative value. Actually, standard deviation is the most important measures of dispersion because it having some special characteristics. Okay. Standard deviation is rigidly defined and it is based on all observations. We are taking all observations of the data and it is useful, it can be used for further treatments or further algebraic treatments, and it possesses many mathematical properties also, and it is not much affected by the fluctuations. If data having the fluctuations, it will not affect in the standard deviation, and it does not ignore the signs of the deviation. In mean deviation, we are taking only the magnitude, does not consider the sign. Whether it is positive or negative, we are taking only the magnitude in the mean deviation. But in standard deviation, the signs are also considered. And coefficient of variation, the relative measure of standard deviation is known as coefficient of variation. The coefficient of variation can be used for compare the variability of two or more series. And standard deviation is used to find out the statistical measures like coefficient of skewness, coefficient of correlation, regression, etc. In all such mathematical calculations or statistical calculations, standard deviation is the most essential one. So, we are going to look how we are solving standard deviation for three type of data, that is individual, discrete and continuous. For individual series, the equation to find out standard deviation is actually this is the equation. For easiness of calculation, we can use this equation. Standard deviation is equal to root of summation x square by n minus summation x by n the whole square. Actually, what is this? Summation x by n is the average. Then coefficient of variation is equal to standard deviation divided by mean into 100. It is always represented in percentage. Then variance. Variance is the square of standard deviation. Now, we are going to problem. This is a question. Raw data. So, what was the equation? Standard deviation is equal to root of summation x square by n minus summation x by n the whole square. That is, we require summation x as well as summation x square. X is the question itself. X square is the squares. 16, 64, 100, 144, 225, 81, 49 and 49. So, summation x is 72 and summation x square we will get 728. Substitute these values in this equation. Standard deviation is equal to root of summation x square is 728 divided by n is 8 minus 72 by 8 the whole square. 728 divided by 8 is 91. 91 minus 72 by 8 is 9. 91 minus 9 square, that is root of 91 minus 81, that is root 10. 3.16. So standard deviation is 3.16. Then coefficient of variation is equal to standard deviation divided by mean into 100. So 3.16 divided by mean is summation x by n. Mean equal to summation x by n, that is 72 by 8, that is 9. So 3.16 divided by 9 into 100, we will get coefficient of variation as 0. Into 100, that means 35.11. Then variance is the square of standard deviation. 3.16 standard deviation square is 10. So variance is 10. So look at the standard deviation of discrete series. This is the equation. Standard deviation is equal to root of summation f into x square. Actually this is the column total of f into x square, that is obtained by multiplying f with x square. Its column total. Summation f into x square divided by capital N minus summation fx by n the whole square. Question: marks and frequency is given. Marks as x, frequency as f. So we have f and x. What are we required? We required summation fx square. Summation fx square means f into x square and its column total. So f is already here. We required x square also. So x is here. So next column is x square. Then f into x square, f into x square. This time summation fx. So fx column also required. These are the column heads. Okay. Always find out the column head from the equation. Look at the equation. It required column total of f into x square. So f is required, x square is required. If you required x square, we need x. Then fx, f into x. N is the column total of f. So n is equal to 50. N is equal to 50. Now x square, squares of x, that is 4, 60, 36, 64 and 100. This is the x square value. So f into x square is obtained by multiplying f with x square. 8 into 4, 32. 10 into 16, 160. 16 into 36, 576. 9 into 64, 576. 7 into 100, 700. So summation f into x square will be 2044. Also we required fx. Okay, that is multiplying by f into x. 2 into 8, 16. 4 into 10, 40. 6 into 16, 96. 8 into 9, 72. 10 into 7, 70. So summation fx equal to 294. So we got fx, n, summation f into x square. Now we are going to find out standard deviation using this equation. Standard deviation is equal to square root of summation f into x square divided by n minus summation fx by n the whole square. Just substituting the values in this equation. Square root of summation f into x square is 2044 divided by n 50 minus summation fx is 294 divided by 50 the whole square. Okay. By simplifying we will get root of 40.88 minus 5.88 the whole square. By simplifying it we will get root of 6.31. The answer is 2.51. So we got standard deviation as 2.51. Next we are going to find out variance. Variance is square of standard deviation, that is what is the square of 2.55? 6.31. So we got variance. Next is coefficient of variation. Coefficient of variation is equal to standard deviation divided by mean into 100. That is, standard deviation is 2.51 divided by mean is, what is the mean? Mean equal to summation fx by n. That already we had find out. Summation fx by n, that is 5.88. So we got standard mean as 5.88. So substitute it in the equation. So we will get coefficient of variation as 42.68%. Now the last type, continuous series, standard deviation in continuous series. Calculate or find equation same as that of discrete series. Find standard deviation, variance and coefficient of variation for the following data. The data set is given. We need to find out the standard deviation, variance and coefficient of variation. So we are going to find out the standard deviation of this data set. Size comes under the head class, frequency f. X value are the mid values of this class, L1 plus L2 divided by 2, we got the x values. Then what else we require? We require summation fx. So fx is required, x square is required, f into x square is required, 22. Now we are going to substitute these values in the equation of standard deviation. Standard deviation is equal to root of summation f into x square divided by n minus summation fx by n the whole square. By substituting it, root of summation f into x square was 1272 divided by n is 24 minus 156 divided by 24 the whole square, which is equal to root of 53 minus 6.5 the whole square. By solving it, we will get standard deviation as 3.28. Now variance equal to square of standard deviation, that is square of 3.28. We will get variance as 10.75. Then coefficient of variation is equal to standard deviation divided by mean into 100. Usually standard deviation is represented by the symbol sigma. Okay, so otherwise we can write sigma by x bar into 100. Both equations are same. By the mean is mean equal to summation fx by n, that is 6.5. So substitute 3.28 divided by 6.5 into 100. We will get coefficient of variation as 50.46. Coefficient of variation as 50.46. Deviation is considered to be the best measure of dispersion. The coefficient of variation is used to determine the variability of two or more series, irrespective of the fact that they are expressed in the same or different units. The series for which the coefficient of variation is less is considered to be more stable or consistent or less variable. We can take two series. If the mean is same, we cannot say that both the series are stable or consistent or not. That I am taking 5, 5, 5, 5. Okay, its average, its x bar is 5, that is 20 divided by 4, that is summation x by n, that is 20 divided by 4, we will get average as 5. And taking another series, 2, 8, 7, 3. 2, 8, 7, 3. When I am finding the x bar of this series, summation x by n, altogether 20, 20 divided by 4, the average is same 5. But look at both series, this series more stable because all the values, all the individual data is same, or it is same as that of the average, but there is a deviation of individual data set from the average. So by only using average, we cannot say that the data is good or bad. For that, we need to find out the standard deviation of the both series. The series which having more coefficient of variation is considered as less consistent series or more variable series. Calculate standard deviation of the following data and state which one is more variable. We need to identify more variable data. More variable means more variable that is having higher coefficient of variation. More consistent means having low coefficient of variation. Okay. So remember it in the mind. Now we are going to find out the standard deviation of the both the data set, that is session A and session B. Data set having marks is same, session A having different number of frequency and session B having different number of frequency. So first we can find out the standard deviation of session A taking the marks and this frequency, then session B taking the mark and this frequency. Okay. So I am going to find out the standard deviation of session A. Class is given, frequency is given, x is the mid value of the class. Then fx, x square, f into x square, these column values are required. So complete the table. So when we are completing the table will be look like this. Then find out the standard deviation. Standard deviation is equal to root of summation f into x square divided by n minus summation fx by n the whole square. So substitute this value, root of 2250 divided by 50 minus 2200 divided by 50 the whole square. By simplifying it, we will get standard deviation as root of 109, that is 10.44. Then coefficient of variation is equal to standard deviation divided by mean into 100. So coefficient variation will be 10.44 divided by mean is summation fx by n. Summation fx by n, by solving it 2200 by 50, we will get mean as 44. So standard deviation divided by mean into 100. So we will get coefficient of variation as 23.72. In section B, when we are completing the table in section B, when we are completing the table, class frequency, session B's frequency is taken, x is the mid value of the class, then complete the table. Then we are going to find out the equation of standard deviation. Now we are going to find out standard deviation using the equation. So data set, standard deviation is equal to root of summation f into x square divided by n minus summation fx by n the whole square. Okay. Okay, so substituting the value, root of 162675 divided by 75 minus 3395 divided by 75 the whole square. Then by solving it, we will get standard deviation as 10.95. Okay, then coefficient of variation is equal to standard deviation divided by mean into 100. Here mean equal to 3395 divided by 75, that is 45.27. Substitute here 10.95 divided by 45.27 into 100. We will get coefficient of variation as 24.19. So coefficient of, look at the standard deviation of two series 10.44, 10.95. There is only a slight variation. But look at the coefficient of variation 23.7 to 24.19. Our question was, which one is more variable? More variable means the series which having higher coefficient of variation, which is having the higher coefficient of variation B. So since coefficient of variation is more for section B, section B is more variable. If the question was which is more consistent, section A is more consistent. Some important notes: standard deviation does not affected by changes in the origin, and for a symmetrical distribution there is a relationship between standard deviation, mean deviation and quarter deviation. For a symmetrical distribution, quarter deviation equal to 2 by 3 into standard deviation, and mean deviation equal to 4 by 5 into standard deviation, range equal to 6 standard deviation. Symmetrical distribution means when we are plotting the frequency, it will looks like a bell shaped curve. Okay, that is, it will be symmetrical about its average. If this is the average, the left side portion is symmetrical to the right side portion. So this is only for symmetrical distribution. And also one more relationship: for a symmetrical distribution, its mean equal to median is equal to mode. So by this we can conclude measures of dispersion. I hope all of you understand about all 4 different types of measures of dispersion, and hope enjoying the class. Thank you.